Okay, in this video, we'll be covering part 3 and part 4 of the January 2023 Geometry Regents exam. We're going to start with part 3. These questions are 4 points each, so there's partial credit here, and we're going to take a look at number 32. Sally and Mary both get ice cream from an ice cream truck. Sally's ice cream is served as a cylinder with a diameter of 4 and a total height of 8. Mary's is served as a cone with a diameter of 7 and a total height of 12.5. Assume the ice cream fills the cylinder and cone. We want to know who is served more ice cream, Sally or Mary. So we're definitely talking about volume in this question, and I would go right to my reference sheet in my test booklet and copy those formulas. So let's start with Sally. So Sally is in a cylinder, so cylinder volume is pi r squared h. Let's fill in the info that we know. Notice they're giving us the diameter, so let's have that for the radius. The height is 8, and I'm going to go right over to my calculator here, and I'm going to type in everything to see what that is equivalent to. Okay, so for Sally's ice cream, I got 100.5309649,149. I'm not going to round anything here. We want to stick with the rule that we just round our final answer. Okay, let's see how much ice cream Mary has. So hers is in a cone shape. The volume of a cone is 1/3 pi r squared h. Again, we were given the diameter, so let's have that for the radius. And we'll plug in our height. Okay, so let's calculate the volume of Mary's ice cream. So 1/3 pi. The r, the radius, is 3.5 squared times the height of 12.5. And I have that the volume of her cone is 160.3521, and we have all of these decimals here that I'm just going to copy over. All right, we want to know who is served more ice cream. Well, certainly Mary's value is higher than Sally's. I ran out of room a little bit here, so I'm going to just write up to the side here that Mary was served more ice cream. Now, since this problem says justify your response, justify just work is sufficient. That's one way to think about it. But you definitely have to have the work there. If you wanted to expand and you want to say Mary was served more ice cream because 160 is greater than 100, something like that, that's also fine. Then it says determine and state how much more is served in the larger ice cream than the smaller ice cream to the nearest cubic centimeter. So we are just going to simply subtract here. Okay, so 160.35 and all of our decimals. This is why it's important not to round early, because that could possibly affect our answer here. And I'm going to subtract those. I'm using my arrow keys in my calculator to copy and paste those numbers so I don't have to type them up. And I got 59.821, so on. But it says to the nearest cubic centimeter, that means the nearest whole number. So I'm going to say 60 centimeters cubed. Okay. As far as the unit goes, by the way, in the previous part, it wasn't asking us about units, but you can certainly add those in here, the cubic centimeters as well. Okay, number 33 is a proof, and I have already gone ahead, set up the statement reason columns, and copied the givens over. So that's how we're going to start every proof, setting up our 2 columns, writing the givens. And if there's anything from the givens that the problem tells you is congruent, mark those off in your diagram. So in this case, we know that AC and DB are in fact congruent to one another. Okay. After we write the givens, we want to read them closely and see if there's anything we can elaborate on. Like, do you read the givens and see any key words or symbols that you've learned about in geometry? And in this problem, I see parallel, and I see parallel again. So I know that in this proof, I should be talking about some sort of angle relationship that has to do with parallel lines. Okay. So here's one that very frequently shows up with parallel lines, and it's talking about alternate interior angles. One way to identify alternate interior angles is to look for a Z shape in your picture. Okay, so if you notice the Z shape that I'm highlighting, the angles in the corner of the Z are alternate interior angles. So I'm going to write angle A and angle D are alternate interior angles. And I know that because parallel lines, right? We know AE and DF are parallel, cut by a transversal. AD is a transversal here. Form alternate interior angles. Keep in mind, too, that some teachers and some solutions on the Regents write things differently. So it's not one cookie cutter answer to any proof. I'm going to now say those angles are congruent. And that's just because alternate interior angles are congruent. So in terms of the point values on the proof, I think it's fair to assume at this point that we would be getting 1 point if we stopped here. The givens must be there, but you don't really earn points for having that alone. But getting the alternate interior angles marked off, so again, that's angle A and angle D, that's definitely worth a point. Now, there was a second given that had to do with parallel lines. And in that one, I'm going to go in a different color here. It tells me that EB and FC are parallel to one another. And when I do that and I kind of stretch them out and connect it, I'm getting not a full Z shape. I mean, I'm getting a Z shape, but the problem is these are the angles in the Z shape, and those are not in the triangles. So what I'm going to actually do is I'm going to use the angles next to those, and I'm going to say that those are not alternate interior, but they're alternate exterior angles. If you think about when you learned about those angle relationships, here are parallel lines, here's the transversal. So here are a pair of alternate interior angles, for instance, AI for alternate interior, in between the parallel lines. And if I take that out, here's a pair of alternate exterior. Notice how if I make that Z shape, they're on the outside of it. Okay. So I'm going to identify in this proof, I'm going to say that angle EBA and angle FCD are alternate exterior angles. I'm actually going to be writing very similar information that lines 2 and 3 had. Because parallel lines cut by a transversal form alternate exterior angles. And in line 5, I'm going to take those same two angles. You know, lots of writing in a proof here. So I'm going to say those same two angles are congruent. And that's because alternate exterior angles are congruent. Oops, let's change that, alternate exterior. I'm used to writing interior for sure, so change those, make those exterior angles. And now if I look at my picture, I have two things marked off in each triangle, two angles. Now, they gave us too much information in terms of the sides. Like, we should agree that AB and DC are actual sides of the triangle, but they gave us too much. So we have to basically subtract out that extra. The way that we do that is we're going to say that BC is congruent to itself by the reflexive property. And based on that, and I'll zoom out a little bit here, that means that AB must be congruent to DC by the subtraction postulate. And I'll explain that once I write that further too. Okay, so if we look at this picture, and I'm going to get rid of some of these highlighting marks here and these congruent marks so you can just see and focus on it a little bit more. We were given that AC, okay, everything I'm highlighting in blue, and DB are congruent. And if you look at that, they are too big. They are bigger than the actual sides of the triangle. So what we want to do is acknowledge the fact that BC is congruent to itself and basically subtract that out. Almost imagine that being removed, like I'm crossing it off here. That will tell me that AB and DC are congruent, and that's called a subtraction postulate, since we're subtracting congruent parts from two congruent segments. So if I look at those triangles, I have 3 markings, and that means my triangles are going to be congruent in this case by angle, side, angle. So my proof statement is always my left statement. And you could write ASA postulate. You could write ASA is congruent to ASA. Those are going to mean the same exact thing here. So now we have fully gone through this proof, and we have shown that those two triangles are congruent to one another. Okay, number 34. Barry wants to find the height of a tree that's modeled in the diagram below. C is a right angle. It gives us some angles of elevation, and it also gives us a distance between 2 points. So the first part says Barry claims triangle ABH is isosceles. Explain why Barry is correct. Notice it is not asking, is Barry correct? It's basically telling us he is. We just have to explain how we know that. So an isosceles triangle has 2 equal sides, but it also has 2 equal angles. And since we're given some angle measurements here, I bet that that's going to be key. So the first thing I notice is this 80-degree angle over here. The one next to it, the adjacent angle, must be 100 degrees because those 2 angles are a linear pair, which means that they're supplementary. So before I even find anything else, I'm going to write that. I'm going to say that angle ABH is equal to 100 degrees because angle ABH and angle HBC are a linear pair, so they are supplementary. You want to keep in mind that these are 4-point problems, so we want to make sure we have enough work or explanations to kind of account for those 4 points. Well, I then have a triangle here. If we take a look, here's a triangle. A triangle always has an interior sum of 180 degrees, and that's going to make this angle up here 40. So I'm going to write that angle AHB is equal to 40 degrees. Because a triangle has an interior angle sum of 180 degrees. Then, since 2 angles of the triangle are congruent or equal, triangle ABH is isosceles, and Barry is correct. Okay, for our second part, it says determine and state to the nearest foot the height of the tree. Well, these angle of elevations to me are indicating that we're going to have to use some trigonometry in this problem, SOHCAHTOA. So let's take a look at the triangle that has the 80 degrees, for instance. We could use the big one with the 40 as well, but let's try and use one of the right triangles because SOHCAHTOA only applies to right triangles. And we're looking for the height of the tree, so I'm just going to put an X here. Now, you might look at this and be like, well, I don't have enough information to set up sine, cosine, or tangent because I don't have any side measures. But we do actually know that this side is 85 feet. And we know that because we just showed in the previous part that this triangle is isosceles. So if there are two equal angles of 40 degrees, there must also be two equal sides, and that makes those 85. Now, based on that, I can go to my picture here and realize that I have the opposite and the hypotenuse with labels on it. So that's sine. So sine of 80 is equal to x over 85. I'm going to cross multiply. I get x is 85 times the sine of 80. Before you put in our calculator, do a quick check. Hit your mode to make sure you're in degree mode. If your calculator doesn't say that at the top, just check that. And now I'm going to type that in. So 85 sine of 80. And we're looking to the nearest foot, so the nearest whole number, and we get 84 feet as our answer here. All right, on to our last problem. Part 4 on the Regents is worth 6 points. So that means there's definitely going to be a good amount of work in here. It's usually some sort of proof. We've already seen like a typical statement reason proof on this exam. So this one happens to be a coordinate proof. So it says we are given triangle DUC and it gives us those coordinates and we want to prove it's a right triangle. So it says the use of the axes on the next page is optional. Anytime I see that, personally, I still plot the points to just kind of visualize what it looks like. So I'm going to go ahead and plot D, which is -3, -1. U, which is -1, 8. And C, which is 8, 6. So I basically just ignore it anytime they say that plotting is optional. I just go ahead and do it anyway. So let's use a straight edge to connect those 3 points to form the triangle. And what I like about doing this and why I like plotting is because it makes it a little bit easier for me to see where the right angle likely is. It looks like that it's going to be over here at U. And that just gives me a little bit more guidance on where to go with my proof. So there's actually 2 ways we could prove that this is a right triangle. We could find the lengths of all of the sides and then plug them into Pythagorean theorem. And if we get a true statement, that means that we do in fact have a right triangle. Or you could find the slopes of the sides and make sure that 2 sides are negative reciprocals of one another. I personally like using distance formula on coordinate proofs, so that's the method that I'm going to take. So I'm going to find the length of DU, UC, and CD. So setting up the distance formula, I want the difference between the x's. So for du, that's a difference of 2 or -2, depending which way you look at it. We'll get the same answer at the end either way. The difference of the y's is 9 or -9. It doesn't matter because you're going to be squaring this, so you're going to get the same answer either way. So when I do this, I have 2 squared and I have 9 squared, so that gives me radical 85. All right, let's do the same thing with UC. I get 9 and 2. I notice these happen to come out to the same value. And then CD. Again, I'm just finding for the first parentheses the difference between the 2 x values. So like for this one, -3 and 8. The difference between those values is 11. And then doing the same thing for the y values. And this time there's 7. And that gives me the square root of 170. So if I plug these values into Pythagorean theorem, the biggest one must be the hypotenuse. So I know radical 170 would be the hypotenuse. I could also look at my picture to verify that. The square root and the squareds basically cancel each other out. So we want to say, is 85 plus 85 equal to 170? Yes, it is. So I'm going to say that triangle DUC is a right triangle. Because its side lengths satisfy the Pythagorean theorem. Anytime you're doing a coordinate proof like this, you should definitely include a sentence like this, just kind of verifying what does your work actually show. Okay, for the rest of question 35, it tells us point U is reflected over DC to form U prime. And we want to prove that quadrilateral DUCU prime is a square. So take note, similar to the Barry question we saw before, it's not asking us, is it a square? We have to prove that it is. It's not a question. So we know a couple of things to help us find U prime. We know that in a square, the opposite sides are parallel to each other. So if I look at UC, for instance, I can see that the slope went down 2, and then it went to the right 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. So if I do that with D, and I go down 2, and then I go over 9 boxes, I'm going to land right here. And that looks like that point is going to be, so that's our U prime, 6, -3. So if I connect this, I'll show you how we can verify that we did that right. When you basically have a line of reflection, it is always perpendicular to the line segment that connects the pre-image and image. So if I actually connect U to U prime, U to U prime should be perpendicular to DC, and that would mean that their slopes are negative reciprocals of one another. So if I check that quickly from U to U prime, it looks like the slope is down 3 over 2. And from D to C, it looks like the slope is up 2 over 3, so that checks out. We do have perpendicular lines there. So again, the slope of, we can even jot this down off to the side here, the slope of U to U prime that slope was going to be -3 over 2, whereas the slope of DC, the slope is 2/3. All right, now let's talk about how we can prove it's a square. Well, we're already partially there because we have figured out that the diagonals are perpendicular, and that is true in a square. We're going to also want to check that they're congruent, though. So I am going to set up some distance calculations. So du, uc, c to u prime, u prime to d, and I'm going to add the diagonals over here, u to u prime, and dc. Now, based on what we've already done in this problem, I actually know some of these measurements. So if I scroll back for a second, I know that du and uc are radical 85. No need to do them again. We already found those measurements. And we also knew that segment CD or DC, whichever, is radical 170. So I already have those 3 measurements. So now I'm just going to do the remainder of the calculations. So just to make this easier, I'm going to just take a second to copy down the points from the question. So D is -3, -1. U is -1, 8. C was 8, 6. And our new point U prime, we figured out was 6, negative 3. All right, let's do a distance formula calculation. So CU, subtract the x's, I get 9. Subtract the y's, I get 2. And this comes out to be radical 85. We're going to do the same thing for U prime D. The difference of the x's is 9. The difference of the y's is 2. And we get radical 85. For U to U prime, when I subtract the x's, I get 7. When I subtract the y's, I have 11, and that gives me radical 170. So we just have to conclude how all this information makes it a square. So I'm going to say that DUCU prime is a square because all sides are congruent and the diagonals are congruent. And that concludes question 35 and the answers to the January 2023 Geometry Regents.